Hello everyone and welcome to a Khan Academy tutorial. We are going to be doing subtracting fractions with unlike denominators. So our problem here is subtract, and we have 5 over 6 minus 8 over 12. The number one thing I see people do is they just subtract the tops, -3, they subtract the bottoms, -6, they convert it to how they think it should look, 3 over 6. They're like, oh, I know, this is 1/2, and they put 1/2, and that's absolutely wrong. You cannot do that. Okay, as I said in a different video, you have to have a common denominator. Why is that? Well, let's say we're having chocolate bars here. Chocolate bars are a good way to go because it's really easy to visualize. 1, 2, 3, 4, 5, 6. So we have, this is this fraction right here. And this fraction has 5 of these chocolate bars, or chocolate pieces, eaten or selected, or they chose that, or they broke that off, whatever. It's 5 out of 6. Now, this one, okay, is not the same. We'll say it's the same side, but it's not divided in the same way. So we couldn't say, let me divide it into 12 real quick. Let's do my best here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so that's 12. I couldn't say that if I had 5 of these ones, I'm going to just kind of fill this in here. If I had 5 of these, 1, 2, 3, 4, 5, that would be the same amount. Look, it only goes to there. So I can't say that these 12s are the same value as those. So I need to make sure that they are before I add them together. Otherwise, I'm comparing small sizes and big sizes and saying that they're the same thing. That's what people do. They're like, oh, I did 5 minus 8 and I had 6 minus 12, but they're not the same thing. You need to convert them to be the same thing. So how does that happen? Well, a lot of times what you do is you convert the smaller denominator to have the same number as the bigger denominator. Why is that? Well, it's easier to split the big pieces up into smaller pieces than it is to go the other way around. So essentially what I'm saying is we can split this. Let me change the red out. We can split this into more pieces. Let's divide each one of these in half, and now we have 12ths. And now we have a better comparison because now we know we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 of these 12th size pieces, these small pieces, 10 of them. And we already knew before, sorry, I didn't actually highlight it yet though. And before we knew we had 1, 2, 3, 4, 5, 6, 7, 8 of these ones. So we wanted to know how many of these pieces we had in total. So we convert it to the smaller one that they both can have a common denominator with, and then we can go from there. So now they're the same size. We have the same size pieces there. This is divided in 12. That's divided in 12. Okay, and this one is 10 out of 12. We had 10 pieces out of 12 total possible, and this one was the same. We had 8 over 12, and we're ready to do our subtraction. How do we do this? Well, we do top, the numerator is known as the top. Use subtract or add them depending on the operation, but we leave the base the same. Okay, the base tells us what size. This is basically what is the size. Okay, this is the whole. This is the whole, and the top part is the part. Okay, so the top is the part, the bottom is the whole. Top is the numerator, bottom is the denominator. But this essentially tells us the size. What is it? What are we working on? What's the total? Okay, and the total is 12. There's 12 total pieces, and how many do we have left when we do 10 minus the 8? Okay, so in this case, we did 10 minus 8, and we get 2 pieces left over. That's 2 over 12. Now we can reduce this. I'm not sure if Khan Academy wants us to reduce this, so I'm going to put 2 out of 12. Whoops, not 22. Oh boy, what is it doing? So that's 12. There we go, and this was only 22, and we're going to check that. And we're good to go. Okay, we didn't need to reduce it. All right, now this one's a little more tricky. Okay, because we have 2 that we need to convert. And I'm going to kind of go into how do we convert these fractions in a little bit more depth in this problem. So we have 6 over 2, and we have negative. Keep that negative sign in front. And I like to put it in the top. Always put negatives in the top. So star, negatives in the top. That's just a really recommended way to go. Now, we want these fractions to have the same denominator. So we have to find the smallest denominator that they have in common. Now, we don't necessarily need to find the smallest one. It's just a good practice to do because it saves you some work. So what are numbers? Okay, like before we saw that 6, the piece, could be, it fits into 12. 6 times 2 gives us 12. So we could divide each one in half. What do 2 and 3 have in common? It's not like we can double 2 to get 3, because that's not the case. So we need to have something that both 2 and 3 go into. Well, we know that 2 goes into 2, 4, 6, 8, 10. Those are all numbers that are multiples of 2. What are multiples of 3? We have 3, 6, 9, 12, 15. Okay. Which of these numbers do they have in common? Well, let me add one here and put 12 there. Okay. Which of these numbers do they have in common? Well, they have 12 in common, but they also have 6 in common. So what do we choose? We want to choose the smallest number. It saves us some work. Why would you choose a bigger number when you can choose a smaller number? So we're going to make this 6. We chose our common denominator. This is our least common denominator. Okay. Now, what are we doing from here? Well, we need to understand, how do we go from 2 to 6? What do we do? Because we can't just make it 6. We can't just say, oh, poof, the denominator is now 6. We need to do something to it. We need to multiply by 3. Okay, so we multiply 2 times 3 gives us 6. Now, we just can't put 6 in the top now. That's not right, because that's not what happens. That we just change the value. What we do to the bottom, we also have to do to the top. So if you multiply 3 to the bottom, we multiply 3 to the top. So we should get 18. Okay? Now, let's do the same thing on the bottom one. How do we go from 3 to 6? Well, we multiply by 2. Can't just change the value like that. We have to multiply what we do in the bottom to the top. So we're going to multiply by 2 here, and we get -2. Now we're ready to subtract. So we had 18 over 6, and then minus, we're going to keep that minus sign there, 2 over 6. Okay, now if you're confused why I'm not doing minus -2 over 6, is because I essentially just converted this 1/3. I took the negative with it, so you just got to put the negative back when you're done. Now I have 18 over 2 minus 2, or excuse me, 18 over 6 minus 2. So I'm going to subtract the tops, keep the base the same, so I get 16 over 6 should be my answer. 16 over 6. Let's check it. All right, next question. Here we go. I like writing it like this. We have 4 over 5. We have, I'm going to show you, you can just make sure you add the negative when you're done. I like putting it in the beforehand, but just remember that negative. I'm going to leave it circled. Okay, so we know we want a common denominator. We need to have the same value when we're adding or subtracting these. So what do we have here? Well, we have 5, 10, 15, 20, okay, 25, 30, 35, 40. Okay, I think that's going to be good enough, hint, hint. Then we have for 8, what are our multiples of 8? 16, 24, 32, 40, 48. Okay, what am I doing? You're like, Mr. West, I have no clue what you're doing here. You're just writing numbers down. We're trying to find numbers that 8 and 5 both fit into. Okay, in our first example, 6 and 12 both fit into 12. Okay, they're both multiples of 12. In the previous example, 2 and 3 both fit into 6. 2 times 3 equals 6. 3 times 2 equals 6. They both fit into 6. 5 and 8, what do they both fit into? I made this little list here so we could look at here and see that 40 is a factor, or excuse me, 5 and 8 are both factors of 40. So we know they both fit into 40. So we're going to put 40 as our common denominator. Now, next step is, how do we go from 8 to 40? How do we change the denominator? Well, we multiply by 5. If we multiply by 5 in the bottom, guess what? Got to do it in the top. So we get 10 out of 40. This is something I forgot to say last time. 10 out of 40 is the same thing as 2 over 8. I just changed how it looked. I gave it a makeover, okay? 10 out of 40, because now we can use it a lot more effectively than we could before. What do we do here? Well, we're going to multiply 5 times something. 5 times 8 gives us 40. 4 times 8 gives us what? 32. So we have 32 in the top. What you do to the bottom, you have to do the top. What you do to the denominator, you got to do to the numerator, okay? So now we have a much easier problem. We have 32 over 40. What's the sign in between? Not plus, the minus. See how essentially the minus stays the same anyway? I just wanted to show you why that is, okay? Then we have 22 over 40 because 32 minus 10 is 22. I don't think it's asking us to reduce. That's a different story, different scenario. So we're going to put 22 out of, what was it, 10? Let me double check that. 40, whoops. 4 and 10 kind of, 40 and 10 kind of look the same. 40. All right, I don't want to have this video be too long, so I hope this was helpful enough for you guys to do well, and I hope to see you next time on Wes Explains Best.